With the remarkable progress in space research, the spacecraft of the European Space Agency, ESA, continue to make groundbreaking discoveries, expanding humanity's understanding of celestial bodies beyond our solar system. Recently, one of the notable events was the monitoring of the interstellar comet 3I/Atlas by the ExoMars Trace Gas Orbiter, TGO, and the Mars Express spacecraft as it passed near Mars. This is one of the rare occasions that ESA spacecraft have had the opportunity to observe an interstellar comet from close range, providing valuable information about the structure and characteristics of this comet, even though it is faint and distant beyond the capability of regular observations. From October 1st to October 7th, the ExoMars Trace Gas Orbiter, TGO, and the Mars Express spacecraft of ESA turned their attention to the interstellar comet 3I/Atlas as it passed close to Mars. Among all ESA spacecraft, the two Mars orbiters had the closest view of the comet. During its closest approach to the red planet on October 3rd, the interstellar object was 30 million kilometers away from them. Each spacecraft used specialized cameras to observe the comet. Both cameras are designed to capture the bright surface of Mars, just a few hundred to a few thousand kilometers below. Scientists are still uncertain about what could happen when observing such a relatively faint target from such a far distance. The ExoMars TGO captured a series of images displayed in the GIF below using the Color and Stereo Surface Imaging System, CASIS. The 3I/Atlas comet appears as a faint white dot moving toward the center of the image. This dot represents the comet's core, consisting of a rocky ice nucleus surrounded by a coma. The images of 3I/Atlas taken by ExoMars TGO. CASIS cannot distinguish between the comet's nucleus and its coma because 3I/Atlas is too far away. Capturing an image of the comet's nucleus, which is several kilometers wide, is as impossible as seeing a mobile phone on the moon from Earth. However, the comet's coma, which spans thousands of kilometers, is clearly visible. The coma forms when 3I/Atlas approaches the Sun. The heat and radiation from the Sun cause the comet to become active, releasing gas and dust, forming a glowing halo around the nucleus. The full size of the coma cannot be measured by CASIS because the brightness of the dust quickly diminishes with the distance from the nucleus. This means the coma fades into noise in the image, typically material from the comets. Coma is drawn into a long tail, which can extend millions of kilometers as the comet gets closer to the Sun. This tail is much fainter than the coma. We cannot see the tail in the CASIS images, but it may become clearer in future observations as the comet heats up and releases more ice. Nick Thomas, the principal investigator for the CASIS camera, explains, "This is a very challenging observation for this instrument. This comet is about 10,000 to 100,000 times fainter than our usual targets. Observing the 3I/Atlas comet from such a distance demonstrates the superiority of modern space technology and opens up many exciting research opportunities on interstellar objects. Although the comet is too far to observe the details of its nucleus or tail, the images from the ExoMars TGO and Mars Express spacecraft have helped scientists identify the vast coma surrounding the comet's nucleus, created by the sublimation process as it approaches the Sun. Despite the many challenges posed by the comet's faintness, these observations provide valuable insights into the characteristics and behavior of this interstellar comet. In the future, as the comet continues its journey toward the Sun, these spacecraft will continue to monitor and record its changes, helping us gain a deeper understanding of these distant objects and the processes that shape them in space.